Hey, so you know how we always talk about the future of tech, right? Well, Quantum Motion, this UK startup, just dropped something absolutely huge. I mean, really, really significant for quantum computing.
Oh, tell me. Like, I saw a headline, but quantum stuff can get super dense. What's the big deal here? Is it like a new type of qubit or something?
It's even cooler, actually. They've unveiled what they're calling the industry's first full stack quantum computer built using standard CMOS technology. CMOS, Cheryl, that's the same stuff in your phone, your laptop, like everything modern electronics wise.
Wait, really? CMOS? So, like the chips that are everywhere already? That seems counterintuitive for quantum. With all the super cold, isolated environments we usually hear about. Why does that matter so much?
Exactly. That's the whole point. CMOS is the backbone of like billions of transistors manufactured annually. By using it, quantum motion is basically tapping into all that existing industrial infrastructure, the supply chains, everything. It could totally accelerate quantum development and, dramatically slash manufacturing costs. It's about moving quantum from these niche labs to widespread industrial use.
Wow, that's a huge shift in approach then. So, if they're using CMOS, what kind of qubits are we talking about here? Because I'm guessing not superconducting, right? Since that needs all the super specialized cooling and stuff.
You got it. They're using spin qubits. These are basically encoding quantum info in the spin of electrons trapped in silicon. And these little guys are just amazing because they're so small, really stable, and guess what? Inherently compatible with those established semiconductor processes like CMOS.
Oh, okay. So it all connects. Spin qubits on silicon. That makes so much more sense now. But how good are they? Like, can they actually perform quantum operations reliably when they're made like this?
Absolutely. Research has already shown that silicon spin qubits can hit over 99% fidelity for quantum operations, even when they're fabricated on, get this, 300 millimeter wafer scale CMOS foundries. So it's not just a lab trick, it's industrial scale potential. And it gets better. Their system has this modular, tile-based architecture. It's like Lego for quantum computers. You can network quantum modules together, just like classical processors scale with multi-core trips. This modularity, it's a huge deal for scaling up and for error correction too. Like the quantum processing unit, or QPU, it actually integrates compute, readout, and control elements into one really dense array. And they can just keep deploying that over and over on a single chip, which is amazing for future upgrades to like millions of qubits.
Millions? That sounds ambitious. And you mentioned full stack earlier. Does that include like the software side too? Because hardware is one thing, but actually using it is another.
Totally. The system combines the QPU with a user interface and industry standard control software. It's compatible with frameworks like Qiskit and Cirq, so it's like ready to integrate into existing computing infrastructure. Plus, get this, it has a super compact footprint, fitting into just three standard 19-inch server racks, so data center friendly, right?
Whoa, that's small for a quantum computer. I was imagining like a whole room. So they're really aiming for practical deployment then, not just, a science project.
Absolutely. They're using AI machine learning for tuning too, for efficient calibration and automated operation, which is critical for scalability. Quantum Motion genuinely aims to bring commercially viable quantum computers to market within this decade. Think drug discovery, energy grid optimization, AI. It's all on the table, Cheryl. It's a really exciting time.